Hey, what's up and how's it going? My name is Toby, and in today's video I want to show you one of my favorite features of the Lightship ARDK, which is live meshing. Live meshing means that basically the scene is recreated within 3D geometry, 3D meshes, so that we can do a ton of cool stuff with that. In this video I want to show you how you can instantiate objects onto the 3D mesh, just as I do that in my personal project, Humming Havoc, that I'm currently working on, in order to pretty much generate a playing field out of trees and plants for our game. So in order to get started, I just have a new Unity scene here with the Lightship ARDK installed. And if you want to know how to do that, I created a whole video on that, but there's also some additional resource in the video description, so just go below and just look it up there. And we just have a new scene here with XR Origin as well as an AR session. And so the very first thing we want to do when trying out meshing is to just create a new empty object, which is going to represent our mesh that is recreating the world. So we're just going to call this mesh prefab. And then we want to add some components to it. Namely, we want to add a mesh filter, which will store all the geometry data, and a mesh renderer, which is going to take a material. And that's basically it for the beginning. And we still want to say cast shadows off, because, well, depends on what you want to do, but if the mesh is supposed to cast shadows, then you can leave this on. I usually turn it off. And then we just want to add a material to it. So we can, for example, go ahead and create in our asset folder a new material here and just call this mesh material. And for example, make this blue. All right, so then on our mesh prefab, we will drag this material so that we can actually see what's going on. And then we want to prefab this mesh prefab. All right, so now we can delete it from our scene. And then in our XR Origin, we're going to create a new empty and call this, for example, AR meshing. Then add a component and choose the AR mesh manager. This is the one that's just from the normal Unity AR foundation, so it's not yet Lightship, but we're gonna add as also a Lightship meshing extension. And this is where all the magic happens, because usually if we want to do meshing, you would need a iPhone Pro version with a LiDAR scanner. That's the only phone that can do meshing with a normal AR foundation, but with Lightship any phone can do it. And so now we have a few settings here, but without tweaking those, let's just quickly drag the mesh prefab into our AR mesh manager and take a look what's going to happen. However, now the question is, how are we going to test it? And there's good and bad news. So the good news is that Lightship provides a very handy tool to test this in editor, which is the playback. So you can pre-record footage and then load it into Unity, and you can see how meshing will work. The bad thing is that with the current beta 4 version, which is the one I'm working on right now, it will only work on a Mac. But in the full release of the ARDK 3, which won't be too long, hopefully, it will also work on Windows. That means if you're currently on a Windows device, you will have to go ahead and build and run on your Android device. But as long as you're on a Mac, then you can, at this moment in time, test in editor. If you're watching this in the future, I'd highly recommend you guys to check whether playback is already available for Windows. All right, so in order to test it, we would need to go into our Lightship settings, and down below here there's a setting that's called playback, and we want to put that in editor and enable it. And now we need to have some data in order to see a video, and I provide you with some samples that you can just download from my Google Drive, and the link will be in the video description, so you don't have to go outside and record something. It's also not just as easy as loading in a normal video, but you would have to go to the ARDK samples, which are imported here, and then build the record scene onto your phone. And Well, if you want to do that, I'll also put some info in the video description, but for right now, feel free to download my pre-recorded samples, and then we can just browse here into a dataset path and choose, for example, I got here the street horizontal example, but for example, we also could take the yard to horizontal still. So these ones have no camera movement, which makes it easier to just see what's going on. And we also want to loop this infinitely. That means if the video is over, it will just start moving backwards and bounce back and forth. All right, so as this one was a horizontal video, so horizontally recorded, we'll also go in a landscape mode and then just hit play and see what happens. Okay, and here we go. We're seeing something happening, but there's just a little bit of mesh which is quite tight to our camera position. So why is that? Well, let's go back into the AR meshing, and we have a setting here that says maximum integration distance. And this setting basically means, well, how many meters away as of an estimated range do you want to have meshing? And of course, the further we go, the more CPU and the more memory it will take. So let's do something like 12 meters. And then next up, there's also the voxel size, which means how small should the individual mesh parts be, right? So if we go too small, then also calculating this will be very intense. But also if we're gonna go too big, then we might have too less detail on our actual voxels. So you gotta know that meshing is quite intense on the CPU, especially if we pump those numbers up. So I'd always recommend to just test out and stay at a number where you just get the result you want, but don't go above it. So for example, I like to set the voxel size to somewhat around 0.05, maybe 0.04. So you get a good mix of level of detail as well as, of course, performance. Something quite similar, here's the density slider, which is from the AR Foundation AR Mesh Manager, and this is about the tessellation. So if you want to have very, very detailed surfaces, then you put that up to 1. I gotta say though that I think that these settings, like the density, would probably work very well with the LiDAR sensor, but from my experience, those settings below here in regards to the detail of the mesh are much more meaningful. So yeah, we have now the maximum distance to 12 meters. Then we reduced, basically we increased the voxel size, so it's a bit less detailed. The mesh block size just means basically how big should be the mesh blocks, which does not affect like the detail of the actual mesh, but rather of how many game objects there will be in our inspector. So for example, if we will do that to a very small number, then we will have hundreds and maybe even thousands of game objects that will have some voxels in them. And if we would make this very big, then we would have just one game object that has all the mesh. And this will be important in the future. For example, if we want to determine if something is a wall or a ground, let's say, depending on how the mesh normals are, then of course having a very big mesh would mean that maybe it can't decide whether it's a ground or wall, because some parts of the mesh are on the ground and some are on the wall. So then also we have this feature of mesh decimation, which is great because we can free up some memory. We just decimate mesh that is behind the camera, out of range, for a longer amount of time, for example. All right, so then the last important setting is the concurrent queue size, which means how many meshes are being processed concurrently. That means if we have 4 meshes at each given frame to be processed, it might take a long time to just get all the meshes right and calculate them so it looks like a realistic depiction of the scene. But if we really crank this value up, then this will of course again take a lot of CPU power. And I usually want to increase this to something like 100, 150, even 200 can be fine. And I'd also recommend you guys to, for example, create a little script that will just get the AR Mesh Manager and then, for example, decrease the concurrent queue size after some time, so that it will reduce the strain on the CPU. Alright, so enough talked about the settings. Let's just click on play again, or if you're on a Windows device, built to your Android and just test it out in your living room. So now we can see it's working much better. We got an actual mesh surface that is being generated and looking quite nice. Also, the level of detail is fine, and as we're here on the street and not, for example, on a tabletop, it's also fine to not have that much level of detail. And still, if you don't have a LiDAR sensor, at least currently, you can get this very fine level of tessellation that a LiDAR sensor would provide. If you have just small objects like a pen on a table, it's going to be quite hard to actually mesh that. So keep that in mind when building your experiences. Alright, so, but how can we actually now instantiate stuff on that to make it look cool? Well, let's go to AR meshing again. And first of all, we want to click on our mesh prefab here, and we want to change the material. And since I imported the ARDK samples, which will be also in the video description, I can go ahead and just change my material here for this invisible mesh with shadow material that the Lightship ARDK provides in its sample package. And so when we just press play now, we wouldn't see anything because it's not only a shadow catcher material and it won't take any color whatsoever. Alright, so then we will now add two scripts to our mesh prefab that you will also find in the video description. A lot of things going on in the video description today, but it will save us a lot of time. So let's add the mesh analyzer and the spawn on AR mesh scripts. So those two scripts, they will have, well, two different functions. The first one, mesh analyzer. What are we going to analyze? Well, we're going to find out whether we have a certain minimum amount of vertices so that we can actually use our mesh. So is it detailed enough, or is it just one point floating somewhere? And then the ground threshold, which is going to determine, are we on the ground or on the wall? Because obviously we don't want to spawn objects on the wall. This will look pretty weird. As for example, a forest, a tree would basically grow on the wall. So the ground threshold, let's set this to 0.44. I tried out some values and it was just pure trial and error. And the minimum verts to maybe 10. And I'm also going to show you how these scripts will work in a second, but first let's see what they do. So then within the spawn objects, we need to actually import some objects. So I went to the Unity Asset Store and I found this free stylized nature environments. And as you guessed it, the link is in the video description. And let's just import them and try to spawn them procedurally on our mesh. So give me a sec here. Alright, so now it's imported and we can go ahead and maybe just quickly lock this view here, go into the environment and then prefabs, and then, yeah, okay, maybe just choose some kind of tree here and add this to our list, or maybe just open up a few slots here and then just add some kind of trees. Doesn't really matter how they look, it's just important to check if the spawning is going correct. So next, minimum verts for spawn. Again here, how detailed should the mesh be for spawning, and here we can actually go a bit higher. A scaler, like if the object might be too big, we just want to quickly scale that down. And the spawn likelihood, of course, if we have a very detailed mesh, then we might have hundreds of objects, just as many objects as meshes. But we want to reduce the likelihood a bit so that the scene doesn't get bloated with any kind of geometry. Alright, so then let's take a look on how this works if we're just gonna hit play. Well, now we can see that something is happening. So if we go to our scene view and just tap out of this prefab here, we can see that some objects are spawning here, and we can also see the shadow that is being casted, right? So we actually got still on mesh, just with a different shadow material, and we got some nice trees here, and we can see they're pretty big. So let's quickly go back and go back to our mesh prefab, And just a reminder, these scripts are actually attached to any spawned mesh, so we will have a lot of them. That's why it's very important to optimize these scripts for performance. Maybe just reduce the scalar to maybe 0.45 or something, and then gonna go back and hit play again. So let's take a look. Perfect, great, this looks great. So this is pretty much exactly the effect that I use for my own project. And what I want you to notice is here on the left side, we can see our trees that are being spawned, but if we go under trackables, we can see all the meshes that are being spawned. And now you can imagine that if now, for example, we set our block size to something that's a lot lower, let's just set that to 0.4 and hope that my computer doesn't explode. If we hit play, we will see that there will be many more game objects being spawned here on the left, and probably we'll also have more trees, right? So yeah, a few more trees, I guess, or maybe it's about the same, but just the amount of trackables you can see, oh my god, it's going quite long. So this is just a matter, it's just a choice of just design, it's a choice of performance, and also a choice of, obviously, if you need a very clear depiction, for example, between wall and ground, let's say, because if we look at this mesh, it's somewhat on the wall, somewhat on the ground. So if you would now try to do a calculation to find out whether it's the ground or the wall, well, it might be a bit more difficult to calculate this. So the smaller your meshes are, the more game objects you have here, the better you can calculate, just as a very simple example here. Alright, so then in order to finish this up, I want to show you what these scripts that we attach actually do and how you can use them for your own projects. So the mesh analyzer, if we open that up, well, we will see that what it pretty much does is it will get the mesh filter, so the component that's pretty much attached to any mesh that we spawn. And if that is not null, so if that actually exists, then we're gonna check whether it has the minimum amount of vertices, so we actually want to use it. And then it will do a quick analysis in order to find out if the normals, so kind of the arrow that is pointing up from each vertices, from each point of the mesh, wherever that points, wherever the average is of that, we will then say, okay, if it's pointing more upwards, it will be the ground, and if it's pointing more to the side, then it will be the wall. So that's pretty much it. And once it's done, it will just invoke an event which says, well, the analysis is done. Now the other meshes can start to do something. And this is quite handy just to start with the analyzer. So based on that information, you can then just trigger, for example, your spawning. So once that is done, we can go to the AR mesh, which is a spawn on AR mesh, which is the other script. And this one, well, if the spawn likelihood is 0, of course it won't do anything, but it will take the mesh analyzer, and as soon as the analysis is done, it will just start spawning. So we will again get the mesh filter, then depending on how likely it is, we will spawn or not spawn an object, and it will just take a random object based on this list that we just populated here a few moments earlier. We'll get a random object, and then it will instantiate this object on a random vector. But this naming is not quite right, because we're going to get the highest vector. And this is something quite important for meshing, because you got to realize that it's pretty much doing guesses on how far the object's away, how far is the scene away, like how much below is the ground. And so it might happen that some vertices, some mesh data is generated somewhere far off, like much below where we actually see the whole mesh going on. That means if we get a random vector from the whole mesh, there is the likelihood that we actually get some kind of random point that is much below or much above the mesh. And so we can play it quite safe by just taking the highest vertex and just comparing all the vertices of the mesh and just taking the highest one, just spawn up on there. And of course, we always have to, if we are talking about the mesh, transform the vertices to the world position. This is quite important. This is an error I've done a lot in the past, because the actual origin or the local position of the vertices is quite different to what the world position actually is. Alright, so these two scripts explained, we now have a scene that will recreate our environment in 3D. It applies a shadow catching material on there, and on the ground it will spawn some elements which then will also cast a shadow. So this is it for a very basic introduction into meshing. If you want to learn more about meshing, please let me know. And you will again find a lot of information and resources in the video description. I really hope that you liked this video, and thanks for watching. See you next time.